Exercise 2.5, problem 4, subdivision 1, discussion. Find the sum of the following finite series 1 plus 0.1 plus 0.01 plus 0.001 plus up to 0.1 to the power of 9. Okay, let's mark. So A is 1, T2 is 0.1 and T3 is 0.01 and the last term, nth term, or L equal to 0.1 to the power of 9. They say a finite series means it's got finite number of elements, so many elements only, because the end point is given, right? So it is finite. If the end point is not given, it's infinite, because we won't know at which point the series is going to end. Okay, so the end point is given here. So let's write it out. So T1 equal to 1, T2 equal to 0.1. Actually T3 also is better, but I missed out. You may want to write it. And the last term L equal to 0.1 to the power of 9. We need to calculate sum of the series Sn. What's the formula? Sn equal to A into 1 minus r to the power of n divided by 1 minus r. And as you can see, A we know, n we don't know, r we don't know, which means we cannot use this formula as of now. And when you come here, you can calculate, okay, so here also r is not known, right? We know nth term, that is the last term, that is Tn equal to a into r to the power of n minus 1. This r is not known, n is not known, right? So which means we cannot use this formula also. Then comes r equal to T2 by T1. That can be calculated because there is 0.1 divided by 1. So r can be calculated. So once you know r, you come to this formula. Okay, so then what happens? R is known, A is known, Tn is known, you can calculate n. Then now you will be having A, R and n. So substitute those values and use this formula to calculate Sn. Okay, so calculate the common ratio using R equal to T2 by T1. But actually you should do one more also, I missed out. Try T3 by T2 also and see whether it is right. 0.01 divided by 0.1 and that is the same, right? 1/10, and 0.1 by 1 is also 1/10. So you find out T2 by T1 as well as T3 by T2, and both are to be equal for a geometric series, because they have not told that it is a geometric series here. If they are told it's a geometric series, then we don't need to use T3. But if not, we have to first make sure that it is a geometric series. So R equal to T2 by T1 equal to T3 by T2. Find both the ratios and check. And if they're equal, this is a geometric progress, and then use the value of R. Next, substitute the values of A, R, which is calculated here, and Tn, or the last term, that is 0.1 to the power of 9, in Tn equal to A, R to the power of n minus 1. So here R is known and A is known, Tn is known, n is the only unknown, we can calculate it. So now you have A value, you have R, you have n. Substitute those three in this formula. A into r to the power of n minus 1 divided by r minus 1, and calculate the sum. Okay, so what I suggest is pause the video here and try to work this problem on your own, and on completion come back and check your working against our solution. What's the solution? R equal to T2 by T1, that is 0.1 by 1. Okay, T2 is 0.1 and T1 is 1. Sorry, this is a mistake here. Okay, T1 is 1 and T2 is 0.1. Okay, and do one more thing also. Find T3 by T2, that is 0.01 by 0.1, that will be also equal to 0.1. So it's a geometric progression and R is 0.1. Okay, I missed out here, please add that step. Now nth term of the geometric series is given by Tn equal to A into r to the power of n minus 1. We know Tn, which is 0.1 to the power of 9, and A is known, A is 1, R is known from this step, and n we can calculate. So this equation becomes 0.1 to the power of 9 equal to A, which is 1, into R, which is 0.1 to the power of n minus 1. 1 into 0.1 to the power of n minus 1 is 0.1 to the power of n minus 1. So n minus 1 will be equal to 9. So n minus 1 will be equal to 9 and n will be equal to 9 plus 1, that's equal to 10. You got it? Two exponents are equal. If they are equal and the bases are equal, then their powers will be equal. So n minus 1 will be equal to 9. That is how we are getting this answer. Okay. Now we have a value, which is 0.1. We have r value. We have n value. So substitute all these three here in this equation. You'll get S10 because n equal to 10, right? Will be equal to a, which is 1, into open bracket 1 minus r to the power of n, that is 0.1 to the power of 10, divided by 1 minus 0.1. Okay, so this is 0.9. So this will become 1 minus 0.1 to the power of 10 divided by 0.9. So this is the final answer. So sum of this series is equal to 1 minus 0.1 to the power of 10 by 0.9. Okay, so that's how this problem needs to be worked out. I hope you got this problem correct. If not, please check where you have gone wrong and make suitable corrections. Thanks for watching this video.